Most of the traditional technologies encounter difficulties while analyzing big data due to its volume, velocity, and variety. As a result, new technologies are created to address these difficulties. Among these technologies, Hadoop is perhaps the most popular name identified with big data. Hadoop was born because search engine innovators like Yahoo and Google needed to find a way to understand the massive amounts of data their engines were collecting and leverage this data for more business. Hadoop was developed as a practical solution to allow companies to manage and process huge volumes of data easily. Hadoop manages different types of big data, whether structured or unstructured, encoded or formatted. This makes it useful for the decision-making process. New nodes, or single commodity hardware server computers, can be easily added in the system when required without altering the data formats, how data is loaded, how programs are written, or modifying the existing applications. Hadoop is an open-source platform and runs on industry-standard hardware. It is also fault-tolerant. Even if a node gets lost or goes out of service, the system automatically reallocates work to another location of the data and continues processing. Hadoop's competencies are getting more and more real-time. It generates cost benefits by reduction in the cost per terabyte of storage. Organizations are synchronizing Hadoop and cloud computing to manage big data. Thus, Hadoop has become a fundamental technology to the success of big data. In this video, we will discuss the components of the Hadoop ecosystem and the process of storing files in the Hadoop Distributed File System, HDFS. Hadoop is the most comprehensive collection of tools and technologies available today. It is often compared to an ecosystem. Just as in an ecosystem, Hadoop is a cohesive system of various tools and techniques for handling big data challenges. Moreover, Hadoop develops and deploys big data solutions with the maximum use of available resources with minimum wastage. So what are the different components of the Hadoop ecosystem? The core components of the Hadoop ecosystem are Hadoop Distributed File System, HDFS, and Hadoop MapReduce. These components provide the basic structure and services needed to support the key requirements of big data solutions. However, just these two tools are not enough to manage big data. The Hadoop ecosystem, therefore, provides a collection of tools and techniques for the complete development and deployment of big data solutions. This ecosystem provides a common technological framework for the different stakeholders such as developers, database administrators, and network managers who build big data solutions. The additional tools and technologies included in the Hadoop ecosystem are Yarn, HBase, Hive, Pig, Scoop, Zookeeper, Flume, and Oozie. As we now understand, Hadoop is not a single solution but a platform with a collection of applications and techniques built on its foundation. Each application has its individual set of functions within the Hadoop ecosystem. For example, HBase is the columnar store. Scoop is responsible for data exchange. Hive manages the SQL queries, and Pig does the scripting. Apart from the open-source Hadoop that was originally created, several commercial versions of Hadoop were later developed, such as Cloudera, Apache, and Hortonworks. These versions were built on the foundation of the basic Hadoop, but with additional capabilities. The Hadoop system can also club with and complement other technologies such as Dremel, HPCC, in deploying big data solutions. The diagram shows the different tools and technologies that are based on Hadoop framework. Together, all these various elements, the Hadoop framework, the core components, commercial distributions, and the related technologies form a comprehensive tool set for targeting different big data solutions. Let us now come back to HDFS, which is the file system of the Hadoop ecosystem, Hadoop's answer to the big data storage challenge. Hadoop Distributed File System is a useful, tough, and clustered approach of storing and managing files. However, remember, HDFS is not the final destination for files. It is rather a data service that offers a unique set of capabilities needed when data volumes and velocity are high. As the name clearly states, HDFS is a distributed file system. A distributed file system is a method of storing and accessing files based in a master-slave architecture. Files are stored on one or more central servers and can be accessed with proper authorization rights by any number of remote clients in the network. Let us understand this in detail. HDFS follows a master-slave cluster design. A cluster is a networked set of nodes. Each HDFS cluster has a single master name node and several slave data nodes. The way HDFS works is by breaking files into a collection of smaller blocks that are distributed among the data nodes in the HDFS cluster and are managed by the name node. The name node performs the administrative functions of opening, closing, and renaming files, while data nodes perform the file read and write functions. It does not store the data of these files itself. Within the HDFS cluster, all the data nodes are collected into racks. Racks are physical collections of data nodes in a single location. The name node uses a rack ID to keep track of all the data nodes in the cluster. The name node tracks the blocks on various data nodes that make up a complete file. But how does this file management system make HDFS an excellent choice for supporting large files? This way of managing files, by breaking them in small blocks, offers a unique set of capabilities for handling large volumes of data. HDFS is resilient. The blocks of data are replicated throughout the cluster to ensure data safety in case of server failures. Unlike other file systems, HDFS allows you to write to a file only once, at the time of creation. This ensures that you can read it from any cached copy of the file replicated on different machines. You do not need to verify whether the contents have been modified. Data nodes and name nodes help implement key features of HDFS, like data safety, data replication, data availability, and data resilience. These features ensure unhindered system performance by directing clients to the nearest replica in case of a single server failure or unavailability. Let's look at an example. A file is used to store contact numbers of people who live in New York. Because the file contains huge amounts of data, it is stored across an HDFS cluster. The contact numbers of people whose last names begin with A are stored on server 1. The ones that begin with B are stored on server 2, and so on. A program collects blocks of files or information from each server to reconstruct the original phone book. In case one or a few components of the server fail to respond, the HDFS replicates file blocks on 2 servers by default to provide the necessary data. This redundancy of data offers high availability. The level of redundancy can also increase or decrease on the per-file basis. Now that you are familiar with the Hadoop ecosystem and understand the HDFS architecture, let's see how much you recall of what you've just seen. If you selected rack, you are correct. Blocks are small pieces of files that are distributed among data nodes. The name node keeps the directory tree of all files in the file system and tracks where across the cluster the file data is kept, and metadata is just data about data. Let's do a quick recap of what you've learned in this session. Hadoop is like an ecosystem that has various tools and techniques required for the development and deployment of big data solutions. The core components of the Hadoop ecosystem are Hadoop Distributed File System, HDFS, and Hadoop MapReduce. The Hadoop ecosystem includes tools and technologies like Yarn, HBase, Hive, Pig, Scoop, Zookeeper, Flume, and Oozie. HDFS is a distributed file system that distributes, manages, and keeps data safe. It is a useful, tough, and clustered approach of storing and managing files. HDFS allows you to write to a file at the time of creation and read it from any cached copy of the file replicated on different machines. This practice makes HDFS an excellent choice for supporting large files. HDFS keeps track of all these pieces of information through metadata. The HDFS architecture comprises data nodes and name nodes that help achieving data safety, replication, availability, and redundancy.